welcome to programming school. And I'm going to start here data structures concept using C, especially using C only. I'm going to discuss here, and I'm going to discuss you all the concepts. What is the stack, queue, and the linear search, binary search, and different types of sorting techniques, a linked list, double linked list, trees, and graphs, and everything. I'm going to start the series of the data structure using C. Okay, and before that, here I'm going to tell you what are the prerequisites. First of all, now I'm not directly jumping into the data structures concept. Before that, I'm going to tell you what are the prerequisites, what topics you will learn in C are the benefit. These topics are benefit when you are working with data structures concept. Okay, before that, what topics I'm going to cover here? First of all, it is going to be searching and different types of sorting. As in searching, that is going to be linear search and binary search. And when coming to the sorting techniques, the basic sorting techniques are going to be selection sort, selection sort, bubble sort, insertion sort, and moving into that is merge sort, and quick sort. And I'm going to tell you some radic sort. And these are the sorting techniques I'm going to cover. In searching, it is going to be linear and binary searching techniques. There are two techniques like this. And after that, I'm going to work with stacks, and then I'm going to work with queues. In queues, the in stacks, we are going to work with how the stack operations are going to be working, and in fix to postfix conversion, in fix to postfix conversion, and in fix to prefix conversion, and how I'm going to evaluate postfix expression, and all these things I'm going to cover here. When we are coming to the queue, in queue, there are what is that? Yes, queue, circular queue, priority queue, double-ended queue, and everything I'm going to discuss in a queues concept. Okay, when coming into the linked list, and coming to the linked list, single linked list operations, and how I'm going to delete and how I'm going to add all the operations. There are totally 7 operations are there, and all the operations on the single linked list, double linked list, circular linked list, double circular linked list, and everything I'm going to discuss in linked list concepts. And coming into the trees concept, and I'm going to write binary trees, and then binary search trees. How I'm going to represent trees and binary search tree, and different operations on binary search tree, and what are the traversal techniques, pre-order, in order, post order, and we are going to work with AVL trees, and the self-balancing trees, and I'm going to discuss all these things in a trees concept. And then graphs concept, and the graphs concept, how we are going to represent the graphs, and what are the different types of representation of graphs, that is matrix, and what is that, linked representation, and what are the Prim's algorithm, Kruskal's algorithm, minimum spanning tree algorithms, these two, and then what are the shortest path algorithms, everything I'm going to discuss about. This is the total overview of my data structure class here. Okay, before that, before that, I'm going to discuss about what are the prerequisites. First of all, uh, I'm going to deal all the topics using C language only. Okay, what are the prerequisites? First of all, we have to know about what are the arrays, and how I'm going to pass array as a function argument, how I'm going to pass it, and how I'm going to what actually it is going to be passed. And the next one is dynamic memory allocation, dynamically how I'm going to create memory for arrays or anything, and I'm going to write how I'm going to create structures, and how I'm going to allocate memory dynamically for the structures, and what are the self-referential structures, and finally I'm going to discuss with the recursion concept. These concepts, recursion concept, and dynamic memory allocation, arrays using functions, dynamic memory allocation, structures, and how I am going to allocate memory for the structures and the recursion. These are the concepts, basically a prerequisites for the data structure. And I am going to discuss all these concepts now. Okay, I'm going to write a simple program first of all. And I'm going to just simply I'm going to read array size, and I'm going to read array values. That's it, nothing else. Percentage d comma percent n. This is array size. Array size this is going to be, and then based on that size, I am going to read the values of the array. Ampersand r of I. In this way, I'm going to read all the values. Just for example, I'm going to print all the values. Again, I'm going to take another for loop, and I'm going to write this same for loop again. And instead of writing scanf, I'm going to write printf here. That's it. Comma error of I. For example, if I'm going to execute it, what is this? Sorry, spelling mistake. CLU. If I'm going to execute it, if it is going to be 5 elements, yes, the all elements are going to be printed here. That's it, nothing else. Just simply I'm going to read 5 elements, and I'm going to read all the values, and I'm going to print all the values. That's it, nothing else. Okay, but here I'm going to write here, I'm going to print all the values, right? For example, now I'm going to print, just simply I'm going to print here percentage d comma arr. What it is going to be print, just simply as I'm, if we go for Python, if you are going to print arr, and it is going to print all the values in the list. But here in C programming language, I'm going to print arr here. What it is going to be handled here, what it is going to be print. For example, if I'm going to execute it, it is not going to be giving any error. Just observe here. Okay, there is no error and warning here. There is no error and warning here. It is going to be 0 and 0. If I'm going to execute the same five values here, same five values, if I'm going to press enter, it is going to be print. We don't know what it is going to be, right? It is the address. Definitely it is going to be an address. What address it is going to be handled? First of all, we have to know about what is the definition of the array. The definition of the array is going to be homogeneous elements, right? It contains homogeneous elements, but it is a linear data structure. It is a linear data structure, and it contains homogeneous elements. That is the definition for the array. That means if we know, that means all the elements are in a continuous memory locations, right? Continuous memory location. First location is going to be at 100, and the next one is 104, 108, and like that. That means all are in a linear fashion. That's why if you know the first elements, first values address, we then definitely we can know, tell that all the remaining address also, right? That's why when you are printing ARR, it is going to be print the address, and that address is first values address. For example, the values are going to be like this, right? The array is going to be like this. What is the first value here? 3. The 3 is at AR of 0, right? It is going to be print AR of 0's address. Okay, for that I am going to print here, I am going to print star here. Star means we know that that is going to be a pointer. Yes, actually the star means it is representing that value at that address. Value at that address is star here. Okay, if I am going to execute it, for example, if it is going to be 5, just observe here what it is going to be print. It is going to be print 3. Everyone just observe here. It is going to be print 3. 3 means that is the first value, right? That means that is an address. I'm going to write here again one more percentage d here, and I'm going to write arr comma star arr. If I'm going to execute it, that is the address, and that is the address, and this is the value. Okay, that means ARR means, what is ARR? I'm asking here, what is ARR? Array, right? Definitely, if you are printing that, that is an address. In the same way, for example, I am going to write here arr comma n. When you are working with functions using an array, when we are passing array as an argument, we are writing like this: one of some function name of arr comma n. N is array size. What is arr? What is arr? I am already discussed about arr, right? Arr is the address of the first element, right? That is the address of the first element, right? Yes, that is an address. Definitely, that is an address. What type of address it is? It is the array's address. First values, array's first value address. That's why when point is coming into the C programming here, what is pointed definition? The pointed definition is it is going to hold the address of another variable of same data type, right? That's why here I'm passing two arguments. When you are working with functions, we have to observe some what are the properties of that function call. Here is the what is the function name? The function name is going to be fun. Okay, how many arguments I'm passing? Two arguments I'm passing. Arr comma n. What are the data types? What types we are passing here? The first one is integer address we are passing, and the next one is integer value we are passing. What we are passing here? We are passing integer address, and the next one is integer value. There are two different values here. Is the function has a written value? No. If any variable, for example, it is going to the function call is assigned to any variable, then we can tell that yes, the function has written value. But here we are not assigning to any variable. That means this function has no written value, and no written value. In this way we have to analyze the properties, actual properties of a function call. Based on that function call, now I am going to write a function definition on this. And what is the written type? There is no written type, right? That's why I'm going to write void here. If the written type is integer, then I'm going to write int. If it is float, I'm going to write float. There is no written type here. That's why I'm going to write void here. Okay. And what is the function name? The function name is going to be like this. And how many arguments it is? It contains two arguments. And what is the first one? The first one is going to be integer address. Yes, pointer is used to hold the address, right? That's why I'm going to write here a pointer, and I'm going to write int star arr. It is not normal variable, it is an address variable, right? This is an address variable. To hold address, I'm going to take a pointer always. I'm going to take a pointer always. Okay. And the next one is a normal variable, right? That is going to be just integer value. We can write like this. Clear, everyone? This is the function definition. For example, if I'm going to compile it, just simply I'm going to compile it. Is there any errors? No, there is no errors, and there is no warnings at all. Okay, clear, everyone? I think, for example, here I'm missing this one. For example, if I'm going to execute it, just observe here, it is going to be giving an error here, some error. Pass some warning: passing argument 1 to function makes integer from pointer without cast. That means I'm not going to be convert this value into this value. That is the mistake here. Okay, that's why I'm going to write star here. Clear, everyone? Just simply I'm going to print at this position. Just simply I'm going to write int I, and for I is equal to 0 and I less than n and I plus plus, and I'm going to print all the values. That's it, nothing else. Percentage d comma space comma, the same thing I'm going to write here also. Okay, simply I'm going to print what are the values in the array. That's it, 5 values, and these values are going to be printed here. My target is not going to be print what are the array values here actually. Okay, what is arr contains, that is my first concept. Okay, how I am going to pass, when I am going to pass a array as an argument, what actually it is going. That is my concept. I think is everyone is understand my concept, right? For example, now how I'm going to create dynamic memory for this. Here I'm using only five bytes. Right here I'm using only, always the array size is going to be 5, and here it is going to be error of 100, right? Error of 100. Remaining 95 memory locations are going to be waste. 95 into 4 memory locations, right? All these are going to be waste. That's why we have to move for the dynamic memory allocation. For dynamic memory allocation, I am going to take here star error. Why I am taking again star error instead of taking normal variable, and I'm going to take a pointer variable here. And why I'm taking array means is going to hold the address of the first value, right? The same thing here also, I'm going to allocate some memory, and the first memory location is going to be allocated at star error here. That's it, nothing else. Okay. And when we are working with the dynamic memory allocation, we have to include one more header file, that is stdlib.h. This header file we have to include when we are going to use dynamic memory allocation functions. That means malloc, calloc, realloc, free. If you want to use these functions, we have to include this header file also. Okay. And coming after reading of the size of the array, and I'm going to write error is equal to int star. I'm going to write malloc of n into size of int here. I'm going to write like this. Int star, that means what type of address we are going to be store here. I'm going to store integer address, and the function name is going to be malloc. N means for example 5. What is the size of integer? That is going to be 4. N into 4, that is going to be 20 bytes we are going to allocate, and the first address is going to be located at err here. Again the same thing, if I am going to execute it, the same thing is going to be happen. There is no difference at all. The previous example is a static memory allocation, and now it becomes a dynamic memory allocation, and remaining everything is same here. Is it clear, everyone? How I am creating malloc? If we are going to using calloc, just simply change here it as a calloc, and here instead of writing n into, we have to write n comma. That's it. Remaining everything is same. For example, if it is 5, the same output, nothing is different here. Is it clear, everyone? Is it clear? Yes. This way, this is the concept, and how I am going to pass an array as a function argument, and how I am going to create a memory dynamically here. Okay. In the next class, I am going to discuss about how I am going to create a structure, and how I am going to allocate memory dynamically using this malloc, calloc functions for the structures, and how I am going to pass structure variable as an argument to the function. And in the next class, I am going to discuss separate class for function recursions, everything. Okay. That's it for today. If you like this video, just please click on the bell button and subscribe my channel. Thank you, guys.